This is Richard from Modern Healthspan. We recently had the chance to talk with Dr. Anthony Corravubias from UCLA to discuss his papers on NAD in aging and CD38, as well as other topics. To provide some background, we would like to talk through two of these key papers.
Here is the first. Senescent cells promote tissue NAD decline during aging via the activation of CD38 macrophages. We know that NAD declines as we age. However, the mechanism of this is not clear. In this study, they looked at M1-like macrophages, which accumulated in fat and liver tissue during aging and in response to chronic and acute inflammation. These M1 macrophages express high levels of CD38, which is an enzyme that consumes NAD and therefore reduces NAD levels. Related to this, senescent cells accumulate in the fat and liver tissue with aging. They then secrete SASP, senescent-associated secretory phenotype, which contains inflammatory chemical signaling molecules called cytokines. These cytokines then induce the proliferation of macrophages expressing CD38. So this shows a causal link between resident macrophages, senescent cells, and tissue NAD decline, and so offers a possible path to therapy to address this decline. But first, what is an M1 macrophage? A macrophage is a type of immune cell. Macro means large and phage to eat, and one of its roles is to engulf and destroy bacterial or other foreign matter within our bodies. At a very high level, a macrophage can become either an M1 or an M2, and we can see here the general characteristics of the types. An M1 is pro-inflammatory with the purpose of killing invaders, while an M2 is anti-inflammatory and promotes tissue repair. Macrophages are attracted to chemical signals of inflammation, as these are normally signs of the body being attacked. Here is a diagram which summarizes the paper. Aging, because of metabolic and genotoxic stress, causes the creation of senescent cells. These senescent cells then produce SASP, which both creates more senescent cells and also causes M1 macrophages to arrive and proliferate. This reaction could also be activated by the presence of PAMPs, or pathogen-associated molecular patterns. A common PAMP is LPS, or lipopolysaccharide, which comes from the outer membrane of some bacteria. LPS in our body is often a sign of leaky gut, where chemicals from the microbes in our intestine leak into our blood, and is more common as we age. For more information on this, you may want to see our talks on microbial burden with Dr. Lustgarten. Both of these have the same effect, which is to cause inflammation and to promote M1 macrophages, which are expressing CD38. This in turn promotes NAD's activity and reduces the NAD levels. In the discussion, the authors sum up: the age-related inflammation drives the polarization of macrophages to an M1 state, characterized by increased expression of CD38. Note, polarization is the process where macrophages become an M1 or an M2 that we spoke about earlier. Cells undergo senescence because of stresses. They show that SASP from senescent cells on its own can increase the expression of CD38 in macrophages and promote further macrophage proliferation. They saw this in older mice and those who had prematurely had senescent cells. So they show a clear link between senescent cells and NAD decline, and that CD38 is an important source for the consumption of NAD, and along with Chinny point the finger at inflammaging. They caution that although the study looked at visceral fat and liver, this process could be common to other tissues in the body. Understanding the crosstalk between CD38 and senescent cells may offer us a way to target this and so reduce the effects on NAD levels and metabolic health.
I do hope that you found the video informative. We will shortly be releasing our interview with Dr. Corravubias, where we discuss the science behind the paper. Please do hit the thumbs up button, subscribe to our channel, and hit the bell button and choose all for any new video release notifications. Thank you so much for your kind support. I wish you all well and will speak to you again soon.